Welcome you all. In this session, we'll discuss about entropy and at the same time, we'll prove that entropy is property. Okay? This is very interesting zone in which we'll slowly enter into real life situation. Okay? So first of all, we need to understand what is entropy, and with the help of this one, by understanding the definition and concept of entropy, will prove that entropy is property. Okay? Right? So first of all, start from this one. Just in figure 1. In figure 1, this is 1A2B1. This is a one cycling process. 1A2B1, this is one reversible cycling process. Reversible cycling process because this 1A2, because this reversible cycling process consists of two processes. One process is 1A2 and next process is 2B1. This reversible cycling process consists of two processes, 1A2 and 2B1, and both processes are reversible. This cycle consists of two reversible processes. That's why this cycle is called reversible cycling process. Okay? This cycle consists of two processes and both processes are reversible. That's why this is called reversible cycling process. Okay? Another cycle is 1A2C1. 1A2C1. Once again, this is another cycling process. In this cycle, once again, there are two processes, 1A2 and 2C1. And since 1A2 is reversible process and 2C1 once again it is reversible process, that's why once again this process is reversible cyclic process. In this reversible cyclic process, there are two processes and both processes are reversible. It consists of two reversible cyclic process. That's why this whole cycle is called reversible cyclic process. Okay? So in this figure, let us suppose that for cycle, for reversible cyclic process, that is 1A2B1. 1A2B1. This is one reversible cyclic process. Okay. We know for reversible cyclic process, for reversible cyclic process, we know that what we know, cyclic integral of dq by t is equal to 0. This equation is only for reversible process, reversible cyclic process, because we have studied this equation in Clausius inequality. As per Clausius inequality, for reversible cyclic process, cyclic integral of dq by t is equal to 0. Okay? So for this cycle, just we are assuming that what will be the cyclic integral of dq by t for this one, dq by t for path A plus dq by t for path B. This will be equal to 0. Let us solve this question now. Since 1A2B1 a reversible cyclic process, and for reversible cyclic process we know that cyclic integral of dq by t is equal to 0. Therefore, we have to find this quantity for this first cycle. This is first cycle. So dq by t for path A plus dq by t for path B, because it consists of only two paths. Therefore, this dq by t for path A plus dq by t for path B is equal to 0. This equation number 1. Similarly, for reversible cyclic process, That is for 1A to C1, 1A to C1. This is another cycle. 1A to C1. Once again, this is reversible cyclic process. Therefore, the cyclic integral of dq by t will be equal to 0. So therefore, dq by t for path A plus dq by t for path C will be equal to 0. Let us put this equation by 2. Very simple approach. We have two reversible cyclic process. For both cyclic process, we are measuring this one, dq by t. So for next part, for next cycle, this is dq by t for path A because it consists of path A and path C. Therefore, this equation equals to 2. Okay. Subtract. Subtract 2 from 1. What will happen? This dq by t path A plus dq by t for path B is equal to 0. This equals number 1 and dq by t for path A plus dq by t for path C is equal to 0. This equal to number 2. We have to subtract this one. This will cancel out. And we have cyclic integral of path B is equal to path C. That means this quantity dq by t for path B and path C both are equal. From this observation, from this calculation, we can say that the quantity dq by t for reversible path B and reversible path C, because this process 2B1 is reversible process and 2C1 is reversible process. So for reversible process, this quantity dq by t will be same. Understand? Only for reversible process, this quantity B and C will be same. Okay? Well, so this quantity. So what is the conclusion? So whatever this quantity dq by t, this quantity does not depend on path. Because this dq by t for path B, this quantity is path B. dq by t for path C, both quantity are same. That means this dq by t will not depend on path. Whatever quantity is this quantity does not depend on path. And this quantity is known as ds, where S is called entropy. This is called entropy. Therefore, ds is equal to dq by t only for remember reversible process. Remember, this is very important. ds is equal to dq by t only for reversible process. Only for reversible process, not for irreversible and so on. So therefore, reversible process, ds is equal to, for reversible process, ds is equal to dq by t for reversible process. This is our one important observation. Let us look at equation number A. Small. Okay? Now, cyclic process. Because this cyclic process consists of two processes and both processes are reversible, therefore it can be said that this cycle is reversible cyclic process. But in next cycle, this is 1A2C1. 1A2 is reversible process, but 2C1 is irreversible process. 2C1 is irreversible process because it is denoted by dotted line. Dotted line represents irreversible process. Therefore, in next cycle, what does it happen? It consists once again two different processes, in which first process is reversible and another process is irreversible. So in this cyclic process, that is 1A2C1, it consists of two processes in which one process is reversible and another process is irreversible. Therefore, it is called irreversible cyclic process. So this is very important. So understand, if any cyclic process, suppose that a cyclic process consists of n different processes. Because in a cyclic process, initial and final point is same. At the end of process, the initial and final point is same. If any cyclic process consists of n number of processes and all processes are reversible, in this condition, this cyclic process will be called reversible cyclic process. But if even a single process becomes irreversible in the cyclic process, then this process will be called irreversible cyclic process. So, first of all, we will discuss about the reversible cyclic process is 1A2B1. Why it is a reversible cyclic process? Because it consists of two processes. This is 1A2 and 2B1, and both processes are reversible. That's why this is called reversible cyclic process. Right? Therefore, for reversible cyclic process, that is for 1A2 B1. Since this is reversible cyclic process, therefore cyclic integral of dq by dt is equal to 0. Yeah? This question. For this cyclic process, just calculate dq by dt for path A plus dq by dt for path B is equal to 0. That is question number 1. dq by dt for path A plus dq by dt for path B is equal to 0. Why it is equal to 0? Because this is reversible cyclic process. Well, now for irreversible cyclic process, that is 1A2C1. This is an irreversible cyclic process. 1A2C1. Why it is called irreversible cyclic process? Because it consists two processes, in which first process is reversible, but another process is irreversible. That's why the combination of one reversible and another irreversible process is called irreversible cyclic process. Okay? So this is irreversible cyclic process. This is 1A2C1. 1A2C1. So for this process, cyclic integral of dq by dt less than 0. Okay? We know this one from this process inequality. Cyclic integral of dq by dt, this process inequality, cyclic integral of dq by dt less than or equal to 0. Okay? So this equal to sign for reversible process and less than sign for irreversible process. Okay? That means this will be dq by dt for path A plus dq by dt for path C. This is less than 0. This is less than 0. Understand, this is very interesting and important derivation. Quite interesting and easy. If you go through basic concept, this derivation is very easy. So there should not be any confusion. Right. So this for path, this is the second equation. dq by dt for path A plus dq by dt for path C because this is irreversible cyclic process. Okay. From equation 1, dq by t path A. dq by t for path A is equal to minus dq by t for path B. From this equation, because this is equal to 0. So dq by t for path A is equal to dq by t for path B. Well, so put this, let us understand this number 3. Replace this path. dq by t for path A by this one. Therefore, from equation number 2 and 3, what we get? This dq by t path B is minus sign plus dq by t for path C. This is essential. This implies dq by t for path B is greater than dq by t for path C. Listen, look, it will go this side. Okay, so dq by t for path B is greater than dq by t for path C. And we know that path B is reversible. This path B is reversible, and for reversible path B, this is equal to ds from this equation. For reversible path, ds is equal to dq by t. So since this path is reversible, this is not reversible, this is irreversible path. For reversible path, this quantity is ds. This quantity is ds. Therefore, ds greater than dq by t. This is for path C, which is irreversible. So, what is our conclusion? For in this condition, ds greater than dq by t for path C. So, what we conclusion we have after this discussion? We can say that ds is equal to dq by t. This is for reversible process, and ds greater than dq by t. This is for irreversible process. If you combine both one, after combining both one, what we get? ds greater than equal to dq by t. This is very important relationship. ds greater than equal to dq by t. So it consists of two conditions. For reversible process and for irreversible process. For reversible process, what? ds is equal to dq by t, and for irreversible, ds greater than. So this is very important result. ds greater than equal to dq by t. For reversible path, for reversible process, ds will be equal to dq by t, and for irreversible path, ds is greater than dq by t. So in the first discussion, what we have seen in first equation? From in this derivation, in this figure, what we have derived that dq by t for path B is equal to for path C. Both are equal. And we can say that this quantity does not depend on reversible path. If path is process reversible, then this quantity does not depend on process. This does not depend on path. So dq by t, whatever quantity is this quantity does not depend on path. That is, this ds vector, dq by t, this quantity does not depend on path. Because both are same. Even though paths are different, but quantity are same. This value are same. Therefore, this quantity does not depend on path. That means S is not path function. It does not depend on path means S is not path function. Therefore, you can say that S is point. Since this is point function, therefore S is called entropy, where S is called entropy. S is called entropy. Therefore, it can be said that entropy is property. Okay? So this is a very beautiful derivation, and you need to go through this derivation very carefully so that you can understand in depth manner. Because this is quite interesting, easy and interesting. If you go through in deep manner, you will come to know what is the beauty of this entropy, what is actually this entropy is. First of all, you need to understand what is entropy. How will define entropy for reversible process and irreversible process. So in this condition, in this derivation, we have defined two things. First thing is that in ds is greater than or equal to dq by t. This ds, in this case, ds will be equal to dq by t for reversible path, reversible process, and for irreversible process, ds will be greater than dq by t. And next point is entropy is property. So this is all about the discussion of this session. Thank you. We will meet in next session.